Today is January 12, 2021, and we are going to discuss two lessons. That is Lesson 5.3, Forms of Conditional Propositions and Logical Equivalence, and Lesson 5.4, Tautologies and Fallacies. So today, let's read first our memory verse. It's found in Isaiah 41, verse 21. It says, "Set forth your case, says the Lord. Bring your proofs, says the King of Jacob." Let's try to look at our MVCA boosters. Equivalence of God's children. Write your personal reflection about this quote. The ground is level at the foot of the cross. So, say something about this as your personal reflection. Let's enumerate our targets. So at the end of this lesson, we will be able to illustrate the different forms of conditional propositions, evaluate the logical equivalence of propositions. All right. So today we are going to read the following. A conditional statement has two parts. Okay. A hypothesis, that is antecedent, and a conclusion, the consequent. In symbols, the statement if P then Q is written as P arrowhead Q. For example, if angles are congruent, that serves our hypothesis, then they have the same angle measurement. Then that serves as our conclusion. So there are forms of conditional propositions. We have conditional, if P then Q, converse, interchanging the hypothesis and the conclusion, if Q then P, inverse, negate the hypothesis and conclusion, if not P then not Q, and contrapositive, if not Q then not P. So we have samples for the following forms of conditional propositions. So let's try to look first the symbols. So this is the symbol for conditional. This is a symbol for converse. This is the symbol for inverse, and this is the symbol for contrapositive. For the sample statement, the conditional proposition, if angles are congruent, then they have the same angle measurement. For converse sample statement, if angles have the same angle measurement, then they are congruent. So they are being interchanged. The conditional proposition is being interchanged in converse proposition. Note, the pronoun must be placed in the conclusion part. Example for inverse, if angles are not congruent, okay, because this is negation of the hypothesis and conclusion, then they do not have the same angle measurement. Okay. For contrapositive proposition, the negation of hypothesis and the conclusion, then interchange them. So we'll just interchange the inverse proposition. If angles do not have the same angle measurement, then they are not congruent. Okay. We have more exercises. Let's read the direction. Write the converse, inverse, and contrapositive forms of the following conditional statements. Letter A. If two integers are odd, then their product is odd. Letter B. If you are in Valencia City, then you are in Bukidnon. So for letter A, let's try to write the converse, the inverse, and the contrapositive. So since the given is a conditional statement, then we are going to copy paste the given. It's a conditional statement. And then the converse, let's interchange the Q and the P. So we have, if the product of two integers is odd, then the integers are odd. For inverse, let's negate it. Okay, if two integers, or let's negate the conditional proposition. If two integers are even, then their product is even. For contrapositive, let's negate the converse. If the product of two integers is even, then the integers are even. So this is an example of our forms of proposition, of conditional proposition. So, okay, so let's try to read this. A conditional statement can be true or false. To show that the conditional statement is false, find one example, called a counterexample, in which the hypothesis is true, but the conclusion is false. So, this is the truth values of the forms of conditional propositions. So here, if the P and Q are true, then the conditional proposition, the result of the conditional proposition is true. If there is a true here, okay. Since we all know that for conditional proposition, if P is true and Q is false, then that is the only false, no, as a result for the conditional proposition. Okay, so note, conditional and contrapositive are equivalent. Okay, as you can see, conditional and contrapositive are equivalent. And converse and inverse are also equivalent. Converse and inverse are also equivalent. So let's try to do these exercises for number 2. Evaluate the truth values of the conditional, converse, inverse, and contrapositive statement in exercise 1B. So the given is, if you are in Valencia City, then you are in Bukidnon. So for conditional, if you are in Valencia City, okay, then you are in Bukidnon. Okay, that's true. For converse, if you are in Bukidnon, then you are in Valencia. That is for converse. Okay, false is the answer. And then inverse, if you are not in Valencia City, then you are not in Bukidnon. False also is the answer. And then the contrapositive, if you are not in Bukidnon, then you are not in Valencia City. So the answer is true. Okay. Note that the conditional and the contrapositive are equivalent. So if the conditional is true, then the contrapositive also is true. And converse and inverse are also equivalent. So converse is false, then the inverse also is false. Okay, let's proceed to okay, the converse is false. You might be at Bukidnon but not in Malaybalay City. The inverse is false. Why? You might not be in Valencia but in Malaybalay City, still in Bukidnon. Okay. Note the truth values of the conditional and contrapositive of this sorry, of the same, while the converse are the same. The converse and inverse truth values are also the same. So here are the conditional equivalents of P, arrowhead Q. If P, then Q. So P implies Q. P is sufficient for Q. If P, comma, Q, Q whenever P. Q is necessary for P. Q if P, P only if Q, Q is implied by P.